Hello, this is Mr. Collier, and today we're going to look at the point-slope form of the equation of a line. So here's what it looks like. So m is slope, and we have a point x1 and y1. So if you have a point on the line, let's say we have 2, 3 or something, then your 2 would go here and your 3 would go here, and this is x, the general xy of any point on the line, and here's the slope. So this is what it looks like. Let's take a look at where it comes from. If you start with the slope formula, this is the slope formula, and what you can do is, what we can do is we can multiply both sides of the equation by x2 minus x1, because that's what's in the denominator here. So we multiply both sides by x2 minus x1, and this cancels, and we have, well, I can just rearrange these sides, and we have y2 minus y1 equals m times x2 minus x1. And if we just, instead of writing a specific point x2, y2, if we use the general point xy, then we have this equation, which is the point-slope form. So the point-slope form basically comes from the slope formula. And we're going to use this. This is sometimes a lot easier to use than slope-intercept form when we're finding the equation of a line, especially if we're given the point and the slope of a line. Then we can just use this formula straight away. So we're going to see how we use this right now. So here in this example, we're given a point, we're given a slope, we have to find the equation of a line. So we can start with the point-slope form, which is y minus y1 equals slope times x minus x1. And we'll use this point as our x1 and y1. So we'll have y, and we'll do y minus -2 and change that in a second. The slope is 2/3, and we have x minus 3. So there's the equation. Now we want to, let's say we want to write this in slope-intercept form. We're going to solve for y in a second. We could do 2/3 time and use distributive property and multiply by everything here, but we're going to actually get rid of 2/3 by multiplying both sides of the equation by 3 in a second. So let me just simplify that a bit, and I'm going to multiply both sides of the equation by 3 to get rid of that fraction. So that'll make things a bit easier at the beginning. And then we're going to get 3y plus 6 equals, and then this 3 and this 3 cancel, so we get 2 times x minus 3. We get 3y plus 6 equals 2x minus 6. And we'll subtract 6 from both sides because we're solving for y here. We'll get 3y equals 2x minus 12. And divide by 3. We'll get y equals 2/3 x minus 4. Alright, so we're done. And in the next equation, or next example here, we have find the equation of a line through 2 points. So just like in the other examples we did, we have to find the slope first. So we're going to use the slope formula to find the slope. I'm going to do that up here. Slope equals y2 minus y1 out of x2 minus x1, which equals, so the y, so let's go this way. -1 minus -2, be careful with your negatives there. -5 minus -2. And then we're going to, so that's like -1 plus 2. In the denominator we have -5 plus 2. And that is 1 out of -3, which is -1/3 is the slope. Alright, so we're going to use that slope in our point-slope form right now. So we have y minus y1 equals m times x2 minus x1. And the y1, well, we can use either point in this case, so it doesn't doesn't matter at all, so I'm going to use this point. So y minus -1 equals slope is -1/3, and we'll have, well, that should be just x there. Alright. So then we have x minus -5. Okay, I'm going to simplify these negatives. That's -1 is +1. -1/3 times x plus 5. Okay, so I'm going to get rid of this fraction here now. So I'm going to multiply both sides of the equation by 3 to get rid of the fraction, and then we'll avoid fractions pretty much the whole equation. So this is going to be -1 times x plus 5. So that's 3y plus 3 equals, let's multiply using the distributive property, -1x minus 5. And solving for y, we'll subtract 3. 3y equals -1x minus 8. And lastly, we're going to divide by 3. So y equals -1/3 x minus 8/3 is your final answer.